shells from one C2 to another. So I am going to give people, as Eve has said, 4 more minutes before we can start. So thank you very much for having me. So I guess we can start at 7:10 as we wait for more people to join.
I think I then acknowledge the presence of Dr. Bright Gambeli today. Maybe you say a word before we start.
Hi, I was supposed to be incognito. Hi, how are you? Yeah, it's nice to be here. I've always wanted to join these sessions, but I always find myself not being able to join. So it's great to be here, and I'm ready to learn something new. So looking forward to learning a few new things that I see as from the post that Martha is going to take us through.
Yeah, Martha will teach us how to pop more shells today. So let's look forward to it.
Sure.
Yeah. Okay, thanks, Bright. Martha, you can go ahead.
Okay, thank you very much. I guess I can start now. So I'll start by sharing my screen. Oh, sorry. Sorry for that. So today we are going to learn how to pass shells from one C2 to another C2. Today we're going to use Covenant and Metasploit as examples of the C2s that we are going to pass shells from. So I am Martha Nyawira. I am a security enthusiast. I work at ICRAL Innovation Hub as a researcher and developer. I am also a trainer and a mentor. So if anyone wants to contact me, these are my details, my Twitter handle, my blog, and my email address. So let's go straight into the objectives. So I divided them into two. The very first step, or part one, is we're going to learn about domain categorization, how we're going to check if our domains are clean. We're also going to learn about domain and DNS configuration. We are also going to generate HTTPS certificates for our Metasploit C2. Then, as of part two, we are going to install Metasploit. We are also going to use Donut to change our Metasploit payload to shellcode. We're also going to learn a bit about process injection and how it happens. Then we are going to finalize on touching a bit on Covenant C2. So right into the introduction. So a C2 server is a computer controlled by an attacker, which is used to send commands to systems compromised by malware and receive stolen data from a target network. So what this basically means is we are going to execute commands to a system, and then we are going to control them. Hence the name command and control. So C2 in full is command and control. Other people know it as CNC. It has several names. So we have examples of C2s here. We have Cobalt Strike, Covenant, and Metasploit, and very, very many others. So these are just but a few examples of the C2s. So one may wonder why we would want to move from one C2 to another. So there are a couple of reasons why we would want to do this. And the very first one, I'm going to just mention a few. The very first one is for backup. So this generally means once we get a shell into our C2, for example, our Covenant C2, it might get banned or it might get caught because the defense team are also really working hard, and they may find your Covenant traffic there, and they may kill it, hence banning it. So backing up would really help this because we will have a backup. So if one C2 is banned, we will still have our shell in another C2. So a shell is a callback or a connection you get back after compromising a particular system. So if you compromise, let's say, my machine remotely, what you get back is a shell or a callback in your C2. The other reason why one would want to move shells from one C2 to another is because some C2s have more exploits as compared to others. The other reason is some C2s offer more modules as compared to other C2s. So we are going to do this in two steps. The very first step is we are going to start Metasploit with a valid certificate. Then the other step is we are going to pass a shell from Covenant to Metasploit. As I had said earlier, we can pass a shell from any C2 to another different C2. But for an example today, we are going to pass a shell from Covenant to Metasploit. So let's start. So the very first step, we need to do domain categorization. So domain categorization assists or helps red teamers in categorizing their infrastructure under arbitrary categories. And this mainly happens for new domains. So once you get a new domain, we would want to categorize it for several reasons. And one of the reasons is to bypass some of the firewalls and also to avoid being blacklisted in the network you're attacking. I have a couple of examples here. So we have facebook.com. We can see it has been categorized under social networking because it's a social networking application. And I also have a different domain here or website, which is kcbgroup.com, which is a bank in Kenya. And it is categorized under the finance and banking category. And as we can see for both of them, we used a tool called Chameleon to check which categories the domains or the websites are categorized in. And so what we're going to do now is we're going to check, we're going to have a small demo here. And we're going to check which category our domain tatula.com is categorized under. As it checks for the domain, here we have commands on how to install Chameleon on your machine. And then this is the usage. So this particular command basically checks which domain, which category your domain has been categorized under. So as we can see, it includes, it has 3 databases. We have the McAfee database, the Blue Coat, and the IBM X-Force database. So the very first DB did not find a category, it's blank. The other one, the Blue Coat DB categorized our domain name as suspicious. And then the IBM DB went into an error. So far, at least we know our domain has been categorized under the suspicious category. So this means when, for example, I'm using this particular domain to attack, it will be dropped or it will be flagged as malicious and dropped because it's categorized under suspicious. So the other thing we need to do is we need to submit it and categorize it under another category. And we're going to use this command with the submit option. So as we can see, the very first DB did not find a category, but then it categorized it under the finance category. The second one is asking us if we want to run it here. We say yes. This one takes a bit of time, and we see, as we had seen earlier, it had categorized it under suspicious. We see this here, and then it shut down. It did not categorize for us. And then the IBM X-Force categorized it under financial category. So this particular tool categorizes each and every domain you submit it under the financial category. And the reason why it does this is once you're attacking a particular network, we see the domains under the financial category always pass through, because most organizations are profit organizations. They won't flag a domain that is under a financial category. So I guess we can move to the next step. Okay. Sorry. Which is checking if our domains are clean. So we need to check this particular step happens for domains that are a bit old. So one can buy new domains or one can buy old domains. So most red teamers prefer old domains because number one, they have already been categorized. Number two, they have a good reputation. So once you get an old domain, we need to check if if it has been used for malicious activities before, or if it has been blacklisted before. And we are going to use Virus Total and MX Toolbox for this. So here's Virus Total. So let me just go back and show you. Okay. Yeah. So once you go to Virus Total, you get this page. So you go to the URL tab, and then you type in your domain name real quick, enter. And as we can see, our particular domain, tatula.com, has not been flagged as malicious. So the other tool we had discussed is MX Toolbox. So again, it has several tabs. We go to the blacklist tab. And then we input your IP address or your domain name. So in our case, we are going to check for our domain name. So it's checking, and we can see it has been blacklisted by one of them, but the rest are okay. So this is how you know if your domain has been blacklisted. It's an X and it shows it's listed. Yeah, so you should make sure it's not listed by any of them. Okay. So the next step we need to do is we are at now domains and DNS configuration. So DNS stands for domain name system. And what this does, it maps your IP address to your domain name. And this makes it easier for finding particular websites. For example, can you imagine if you're checking for maybe facebook.com and maybe DNS configuration and domains were not existing? So we would have to master each and every IP address of each and every application or website we would want to go through. So that would be very, very hectic. So domains and DNS configuration really assisted in that. And here we see a couple of domain registrars. So there's DreamHost, Namecheap, domain.com, and GoDaddy. There are so many. These are just but a few. And today we are going to use Namecheap. So you can choose them according to your preference, or maybe the pricing, anything. Yeah. So this is our Namecheap. So for example, if we wanted to look for a domain for maybe SheHack, right? So this is where we would search for it. Sorry. So it gives you a list of domains, and then you choose the best according to maybe the way you'd want your domain to be, shehacks.io, .com, and then it's still loading. Over here, it will give you the pricing. So yeah, we can see some have shown up. So yeah, you choose according to maybe the price you'd want, and also the domain name you'd want. So let's go back to our dashboard. So once you've bought your domain, for example, I bought tatula.com, you go to the Manage tab. And then you go to the Advanced DNS tab to configure our DNS. So here it is. So we are going to set 2 A records. We're going to set the and the www a record. So this is where we input our IP address that we want to map to our domain name. Also, something to note is this TTL. TTL is time to live. So this means when we input our information here, our information is cached for a while. So it's cached for the minutes that we're going to input here. Yeah. So the recommended time is 5 minutes and below. It's recommended you set the shortest time possible, because that's when it will be automatically refreshed to appear. Yeah, this is for automatic refreshing. So then we're going to save it by clicking on the tick. Then we can verify if it has been configured over here by the DNS checker. So again, this is where we input our domain name, and we set the A record, and then we search. So we are searching, these are name servers in the world, and we want to check if our DNS has propagated, and we can see they're all ticked, so it has propagated. So we did not set a TXT record. So once we search it, we can see it has not propagated. So this basically just checks the whatever you inputted in your name chip, if it has reflected, and we can see it has. So we can move on to the other step. So we are now going to input, or we are now going to generate a HTTPS certificate for our Metasploit. And we are going to use Let's Encrypt. So Let's Encrypt is a non-profit certificate authority that provides transport layer security encryption with no charge. So it's free. And we are going to use a tool called Chatbot, which is also open source and free, this tool will automatically use the Let's Encrypt certificate to manually administer it to our website or our domain, hence enabling HTTPS. And I have a demo for that. Here. Now we're in step 3. So we are going to install Chatbot using this command. Then later, after we have installed, I already installed mine, we are now going to install it and add our domain name, tatula.com. And this is what we are going to see. If it's successful, it will have a congratulatory message that we have successfully had our generated certificates for our domain. And for us to see this, we're going to see the certificates Chatbot generates for us. So the certificates are stored in this directory. So we're going to jump right in. And we have to do this as root. So we can see it's generated for us 4 certificates: the start.pam certificate, the chain.pam certificate, full chain.pam certificate, and the brave.pam certificate. The next step, we are going to merge the sat.pam certificate and the priv.pam certificate to form one certificate. And I'm going to explain why we need to do that. And we are going to use this command. So we need to merge them because Metasploit understands the certificates while they are merged, or Metasploit uses the sat.pam and the priv.pam certificates while they are combined. So we have combined them using, we took the sat.pam and the priv.pam, and we combined them to form tatula.pam. We also, after generating them, we copied them to this particular directory, our MSF directory. Also, we need to check if, you remember, we need to verify this. We need to verify that our domain name has picked the HTTPS. So we're going to do that by going to our URL, tatula.com, and we can see it has picked the HTTPS certificate. You can see over here, HTTPS. So that's good. Okay. So right now, we are now going to install Metasploit. Metasploit is, as I had said earlier, is one of the very many C2s. And this particular C2 is open source, and it's used to probe systematic vulnerabilities on networks and servers. Metasploit has been there for a very long time, and it has so many exploits because each and every time exploits keep on being added each and every time. And we're going to use nightly installers to install it. And then later we are going to generate an MSF payload using MSF Venom. Back to the demo. So here we are. Go to the screen. Cool. So we go back to our user, to Tatula, and we go back to our home. Okay. So nightly installer is a very light installer. I prefer using nightly installer to install MSF because it's really light and it's fast, and it's not problematic. It doesn't have a lot of errors when installing it, sorry. So this is the one-liner over here, and we can check using this command if it was installed successfully. So MSF console is used to start Metasploit, and we can see Metasploit was successfully installed because we can see the help tab and we can see several options one can use using MSF console. Okay, so we can go to our MSF directory over here. So I want us to now generate an MSF payload, and we are going to use MSF Venom to install it, to generate a payload. So we're going to use MSF Venom, and the payload that we're going to generate is reverse HTTPS payloads. There are several payloads. There are so many. but today we are focusing on the reverse HTTPS payload. And as for the L host, this will be our IP address, which is 174.138.21.216. And then we are going to input the port that we're going to listen to. We are listening using port 8443. And then the format we want our payload to be in is in the exe format. And we are calling our payload MSF HTTPS.exe. And it was generated successfully. We can see this by doing ls, and we can see our payload over here. So you remember the certificate we had generated earlier. We put it into our MSF payload, and here it is. And this is generated. The MSF install comes when you're installing MSF over, according to our commands over here. So nice. Let's go back to our slides. And we are now at step 5, which is installing Donut and knowing what Donut is and what it does. So Donut is a position-independent code that enables in-memory execution of VB scripts, JScripts, EXEs, DLL files, and .NET assemblies. So in our case, we have an EXE. Yeah. So Donut basically gets our MSF EXE payload, and then it gets our MSF.exe payload and then generates it into our shell code. So Donut it has a good advantage when it comes to changing EXEs to shell code. And the advantage is after the file is loaded and executed in memory, the original reference is erased to deter memory scanners. So what this means is, so once our EXE is generated, once our shell code EXE is changed into shell code, it does not leave any original reference. Hence, when AVs are there, they won't detect it. It won't be detected as malicious. It erases our original reference and then to deter memory scanners. I hope that is clear. So we are going back to our demo. So these are the commands to install Donut in Linux. So I had already installed Donut. Oh, sorry, I had already installed Donut in my VPS. So here it is. So we're now going to move our MSF payload that we generated using MSF Venom. And we're copying it into our Donut directory. And then we are going to convert it to shellcode using this command. So Donut picks several formats. It picks, you can generate for a 64-bit machine. You can generate for a 32-bit machine, and you can also generate a shellcode for both 64 and 32-bit machine. So this generally depends on your target, the target that you want to exploit. So in our case, it's a 64-bit machine. Later, we are now going to host our bin file into our payload server. So my VPS also acts as a payload server. I am going to explain why we need to upload it or to host it in a payload server. So we can go back to our slides. Okay. We are now at the process injection stage. So process injection, it's a widespread defense evasion technique employed often within malware and entails running custom code within the address space of another process. So I'm going to explain this, this sentence further with a diagram. But generally, process injection really helps in defense evasion. And there are numerous techniques for process injection. So there is DLL injection, process hollowing, APC injection that we're going to discuss and focus on today. And there's also vanilla process injection. So let me discuss APC injection. We need to know what APC is, or asynchronous procedure call. So it's a function that executes asynchronously or independently in the context of a particular thread. So for example, we now have our donut shellcode over here, and this is the process we want to inject to, which is Internet Explorer. So back to our sentence over here, we said what process injection does, it evades detection by AVs by running custom code within the address space of another process. So back to our diagram here. So our custom code is the donut shellcode over here. And then our target process is Internet Explorer. So what it does is the APC injection makes sure we have an address space over here, an empty address space, so that we can write our shellcode into the address space. So when we are running the Internet Explorer, it's not the original Internet Explorer that is running, but Internet Explorer with our custom donut shellcode. Okay, so let me expound further on how the APC injection occurs. So we will get our, for example, if our target process or the process that we want to inject to is Explorer. So we need to get Explorer's process ID. So this is the verbose of process injection once it's ran. So we get the process ID of Explorer, and then we get a handle. We get the handle from explorer.exe. So we can see here, we get the Explorer process ID, which is 9584. Then we get the handle from explorer.exe. We then create a process, which will then leave an address space, or a process, it will create a process in memory or an address space. We are then going to write our donut shell code into that address space that was left once our process was created. Then the next step is we are going to attach our shell code that is already now written into this address space. We're going to attach it into the APC function or the asynchronous procedure call. Then we are going to resume and close the thread. So right here, when we see that after resuming the thread, this stage, we will successfully inject the shellcode into the memory process of our process ID Explorer, which was 9584. I hope this is clear how APC injection occurs. So we're now going to we're going to use a tool called process injection for this. Process injection was a tool by Exploit Coder. He wrote a blog about it and also wrote code on it. And you remember when we generated our donut shell code, we hosted it. So we have an option. You can either host it on a payload server, or you can write it on disk and reference it. So I prefer hosting my shellcode. So this is the URL where I hosted my shellcode. And then after execution, we will get a shell in our Metasploit. So we can have a demo to explain these slides. So right here is where we hosted our shellcode to this URL. So the very next step is we're now going to start our MSF, our Metasploit, using MSF console. Great. We are going to use the multi-handler listener for this. Sorry. We're going to use the multi-handler listener. And you see, by default, it gives us reverse TCP payload. By default, it configured for us a payload that's reverse TCP. So we need to change that. So we are going to set our payload to reverse HTTPS. Then we're going to set our L host. And our L host is going to be our IP address. Oh, we forgot a 6. IP address. We are then going to listen on port 8443. And remember, these are the configurations that we did when we were generating our MSF payload over here. So it needs to resemble our MSF payload. We set our L host as our IP address, and we were listening at port 8443. It has to be similar when you're generating the listener. We are then going to use our HTTPS certificate we generated using StatBot. The final step is we are going to verify that our certificate is indeed true or correct or legit. Then we're going to run this. So our MSF is listening. So we now go to our target machine, which is our Windows 10 machine. Here it is. Our MSF payload that we generated using MSF Venom and passed it through process injection. So we're going to execute it, and we can see over here, after executing it, After execution, it spawns iExplore. So something else to note is we can go to our network tab and we see our iExplore is listening to, is communicating to our IP address and the port, our port 8443. So this means when we go back to our MSF, we have gotten a shell or grant back. And we can check if this is correct by checking the system information. And yes, we can see our machine is Windows 10 and the build is 19042. Oh, something else I forgot to show you. Our target machine was, as we said, process injection, evade detections, AVs, and so on. So once we come here, we see our real-time protection is up and our cloud protection is also up. So that means it has evaded Defender, Windows Defender. Something else to note is we should never, once you're making payloads and whatnot, we should never turn on automatic sample submission. And this is because once you have, for example, generated a virus or a payload, then you execute it, and then Windows Defender doesn't know if it's malicious or it's not malicious. So if it's 50-50 about it, it's going to submit it to Microsoft, and then all your day's work it just goes like that. So that's something to note. So yeah, I guess now we are done with part one. We have generated an MSF payload, and then we have executed it, and we have a shell on our MSF, and we did that using encryption, HTTPS encryption. So we are almost done now. So what's left is passing our shell from Covenant to Metasploit. So we're going to start Metasploit, and then we're going to dive in to Covenant. So before we do that, we need to kill this shell so that we just see a new shell spawning in MSF. So that's done. And we should also check, escape, yeah. Should also exit this shell. Our MSF, the previous one. So it has been shut down, it has been closed. So for the next step, which is passing our MSF payload using Covenant, we need to start Metasploit again, or just make sure it's listening and this IP address and the same port. So we're just going to run it since everything is the same. The IP address, the certificate, generally everything here is the same. So we are going to run it again. Then we're going back to our slides. So we've started MSF, and now we're going to focus on our second C2, which is Covenant. So Covenant is a C2 that uses the .NET Tradecraft. And the one advantage of Covenant is it serves as a collaborative command and control platform for red teamers. What I mean here is we can use, for example, we are a team of 5. We can use one covenant, but using different profiles. So each and every, for the team of 5, everyone will have a different profile, but we can use the same C2, which is covenant. And this is really, really good for collaboration and also teamwork, because we can see what the other team member is doing in that particular C2. So in covenant, we are going to generate a grant, and then we're going to interact with it. Let me just dive into covenant and do this practically. Cool. So this is our covenant C2 right here, and this is the dashboard. It gives us the grant, listener, if you have any, and the tasks you've been doing before. So I won't talk a lot on covenant because Labu did an awesome job. He explained covenant in detail. So what I'm going to do today is just scan through it. So we need to create a listener, which I did. And our listening port on covenant is 8080. And this is where we're going to input our IP address. So as you can see, I named it as HTTPS, but it's a HTTP listener because it does not have a certificate. It's false. So the other module, it has a launchers. So we have several launchers or several payloads. You might call them payloads, launchers, any can do. And we're going to use, I used binary. So here we input the listener we made over here. We use the grant HTTP, and the .NET version, we're going to use net 40 for Windows 10. We are then going to generate it. So after generation, you can either download it or you can host it. It has several options, or host it, or just take the code and you take the code and compile it. You compile it by yourself instead of using the generated one. So grants, this is where after executing the covenant payload, this is where the shell comes back. The covenant, the grant base. So we're going to go back to our victim machine yet again. So I had already generated a covenant C2, and once we execute it, it also spawns iExplore. So once we come back to our covenant, we should get a grant back. Okay. So we need to interact with our grant. And then go to, we can see our grant is active. Username, these are just details about the grant. We go to the task tab, and we are going to use assembly.load module to load our MSF payload in memory. So this is an added advantage when you use assembly.load module as compared to uploading it to your victim machine and then executing it, because it won't touch disk, hence it won't be flagged or it won't be caught by the AVs. So we use the assembly.load module. We then choose our payload, our MSF payload that we had generated using MSF. Then you can give it a random name. So I gave it updater. Then we're going to task it. So remember, our MSF is still listening over here. So we see, so it has executed the MSF payload, and right here, we see our shell. Give it a minute. Our shell has come back to MSF. Here it is. So we have successfully, yes, and it's the same machine, Windows machine, same build. Defender is still on. So this proves we have successfully moved our shell from Covenant C2 to our MSF C2. So I think we're going to finalize now. So we discussed about the assembly.load. We saw the results on both Covenant and MSF. So my conclusion is this basically shows how one can move shells from one C2 to another. And I conclude by saying happy hacking. And these are my references. Thank you, and any questions. Also, thanks SlidesGo for the amazing slides. Credits for the slides go to SlidesGo. So, okay, any questions? Any questions? Also, I can see one question here. One is asking from Mike, what's the advantage of switching to MSF? So I personally switched to, the advantage of switching to MSF, according to me, is it has download recursively. So it has a module that downloads recursively, and in Covenant, you can't download recursively. What I mean is, if you get a shell and you want to download data from that victim, from a victim's machine, you have to download it one by one in Covenant. But as of Metasploit, you can download recursively. You can just leave it running and it will download. So long as you've inputted the directory you want to download from, it will download everything from that directory. So I'm going to share the slides with Eve, and she can share the slides and the commands if you need the commands. Or something to add is, let me share my screen a bit again. You can also follow step by step. Sorry, what is the... think I've shared the wrong screen. Oh. Yeah, this is the screen I'm looking for. So you can also follow step by step using the blog. I've written everything step by step. You can follow it. And if you didn't understand anything when you were reading the blog, I believe now, or I hope you've understood something small using the presentation that I've done. I don't think I can see any other questions. Thank you very much. I will share the slides. I would also share the link of the blog. Oh, there's another question from Mike again. Could that mess up your OPSEC? Many files exfiltrated at once. No, it won't mess up your OPSEC, because remember, when you're doing this, you're on VPN, and basically by downloading recursively will help you. Each time it will help save time, because you're not there downloading the file one by one. You can just leave it downloading as you move on. You just come and check if, for example, the download directory has it downloaded everything from there, then you move to the next directory. So no, it won't mess up your OPSEC. I can't see any other questions. Okay, thank you very much. Thank you very much. I think now Eve can take over.
Thank you, Martha, as I wait for Eve to come back. Yeah, it's been a very good presentation. I'm sure people have learned a lot. For the people who was the person who was asking about the recording, it's on our YouTube channel. Just check She Hacks KE. We usually post it live, so you'll find it on our channel. And also for the presentation, we're going to share that with you as well. And you can also check Martha's blog. She has she has this written down, so you can always follow that as well as the recording. So yeah, thank you so much, Martha. Eve?
Hi everyone. Eve isn't available right now, but I can go ahead and close the meeting. I'd like to thank our speaker Martha, and thank you, Laura, for hosting. And I'm glad everyone showed up. Thank you so much. We really appreciate the support. And if we're all ready, I'd like to let you go and have a good night and good evening.
Yeah, thanks, Maria. Good night, everyone.